Hello students, in the last class we have discussed that is the pH and the one problem I have completed on the pH here. We will take the next one, the second problem. The concentration of hydrogen ion, the concentration of hydrogen ion in a simple soft drink is simple soft drink is 3.8 into 10 raised to minus 3 molarity. What is its pH? What is its pH? Okay. So see on the questions here. So the given question is, what is the question is here? The concentration of hydrogen ion in a simple soft drink is 3.8 into 10 raised to minus 3 molarity is there. What is its pH here? Then we have to use the pH formula here. What is the pH formula? Is that pH is equal to the negative logarithm of base 10 to the hydronium ion concentration or hydrogen ion concentration. Okay, that you have done. What is the formula? Is that H3O plus solution. We know the formula, that is the pH is equal to. Before that one, you have to know the hydronium ion concentration is how much here? H3O plus hydrogen or hydronium ion concentration. Next one. First I will you have to write down the pH formula is there. pH is equal to what? Negative logarithm of H plus ion concentration here. Negative logarithm of H plus ion concentration. So here we know that here negative log to the base 10. If I have not written here 10 here means, so you have to understand that 10 will be there here. If I have not written also, you have to consider that here 10 is there, log 10. Okay. 10 into hydronium ion concentration. We are given hydrogen ion in a simple drink is what? That is 3.8 into 10 raised to minus 3. We are writing the hydrogen ion concentration. Next what you have to do here is, so you have to learn about there is a log A into B. Log A into B, how we are writing here? Log A plus log B we are writing. Suppose here minus is there means what we have to do? Minus log A minus log B. Log A into B. This is A, this is B. Log A into B, we have to write what? Log A plus log B. Here minus is there. Minus log A into B equal to minus log A into minus log B. Okay, that you have to write down here. There is a minus log to the base 10 into 3.8. Log A is there, this one, minus log B, log to the power 10 into 10 raised to minus 3. 10 raised to minus 3. Log A into log B, that is we are written as log A plus log B. There is minus there means minus log A into log B. So minus log A minus log B. Okay. Then also in this one, log 10 into 10 raised to minus 3 is there. It is looking like a what? Log A raised to B. A raised to B. What is the log A raised to B? B log A. Log A raised to B or log m raised to n. How we are writing? So I will write down here log m raised to n. How we are writing here? N log m. Like that we are writing here. So if you are writing this log m raised to n is there, 10 raised to minus is there. If you simplify that one, what you are getting here? There is the answer is what? minus log 3.8 into minus log 10 minus 3 there, log m raised to n is there, means how we are written n log m. N is what, 3 is there, minus 3 into log 10 like that we are written here. Next one, when you see here log 3.8, what is the value you are getting? 3.8. So suppose first you have to simplify this one, minus into minus, it becomes plus 3 here. It becomes what? Plus 3. Log 10 value is what? Already I have to do that. Log 10 value is always 1 is there here. Log 10 value 1 is there. So 1 into minus 3, minus 3. Minus 3 into minus, plus 3 here. Then what you can say? Minus log 3.8 plus 3. So you have to use the logarithm table and find out the log 3.8. What is the value is there here? So in the physics also they have explained about how to find out the logarithm and anti-logarithm. So in this chapter, the finding the logarithm and anti-logarithm is very important for solving the problems here. I hope that you already know about that logarithm table. No need to explain it once again here. Okay. So here log 3.8 value, what is the value you are getting here means? So you are getting the value is what? 0.58 minus 0.58. In the 38 number is there, no? And that one you have to find out that one you are getting the value is what? 0.58 plus 3 is there here. When you are doing this one, we are getting the value is what? Minus 0.5 plus 3. What is the value getting? That is the 2.42. So this is the what? pH. We have found out what? pH. pH is what is there here? That is the 2.42. So this is the what we have found out at what? We have found out at the hydrogen ion concentration in a soft drink. That is the hydrogen concentration is what? 3.8 is there into 10 raised to minus 3 molarity is there. Now we are found out at what? We are found out at the pH. Next one. Next one is the pOH. We are studying about what? In the last class, pH. pH means what? Negative logarithm of base into the hydrogen ion concentration or hydronium ion concentration. So we have to study about the pOH. pOH. What is the meaning of this pOH? As you defined that is the pH. Like that also you have to define the pOH. What is the meaning of this pH definition here? What is the definition there? Is there here means the pH of a solution is defined as pOH of a solution. pH of a solution is defined as negative logarithm of negative logarithm of base 10 of hydroxyl ion concentration. Hydroxyl ion concentration. What is the meaning of pH here? pH of a solution is defined as the negative logarithm of base 10 to the hydroxyl ion concentration. In the pH we are writing at what? We are writing as a hydronium ion concentration or hydrogen ion concentration. But you have to write down what here? So hydroxyl ion concentration. So what is the expression is this, sir? Can you tell the expression here means that you have to write down what? pOH is equal to negative log to the base 10 is there. Base 10 to what? Hydroxyl ion concentration. Hydroxyl means what? OH means concentration. hydroxylate concentration. Okay. So this is the what? The definition of what? Definition of POH. Next one, we have to find that, we have to prove that pH plus POH is equal to 14. pH plus POH is equal to 14 here. Next one, prove pH plus POH is equal to 14. So you have to one derivation is a very important one. For the 2 marks in the examination they are asking this question here. Prove that pH plus POH is equal to 14. So how we have to prove here means in the last derivation I had explained that ionic product of water. In that one we understand that we know that what we know that here we know that H3O plus into OH minus equal to 10 raised to minus 14, that we know here. In the ionic product of water, we have found out that when the dissociation of dissociation of water is taking place in a small extent, then we have studied that here the H3O plus into OH minus is equal to 10 raised to minus 14. The concentration of H3O plus is 10 raised to minus 7 is there. For OH minus it will be 10 raised to minus 7 is there. If you multiply 10 raised to minus 7 into 10 raised to minus 7, then you are getting what? When you multiply that one, you are getting the answer is what? 10 raised to minus 14. 10 raised to minus 14 at 298 Kelvin. That you know in the last class, in the ionic product of water. So here next one, we know that here means, so you have to take log on both sides here. This reaction we have to take taking log on both sides, taking log on both sides. Okay. Then what it becomes here? You see here log of H3O plus log of OH minus is equal to log of 10 raised to minus 14. Okay, you see here log 10 raised to minus 14 is there here. So already I have told you that log m raised to n is there, means how we have to write here? N log m. Like that you can also write on here. So I will write on that one, log m raised to n equal to what? N log m. Like that also you can write on here. So it is looking at like a what? Log m raised to n is there. Suppose if I write on here like that here means, so what happens here? Log minus 14 log to the base 10. This one you have to write as it is here. Log H3O plus log of OH minus m constant, that is equal to minus 14 log 10 here. So we know that what is the log 10 value is there? Log 10 value will be 1 is there means. So then it becomes what? Log of H3O plus log of OH minus is equal to 14. We are taking here 14 here. Why? Because means, so log 10 value will be 1 is there, 1 into minus 14 minus 15 is there. Next one, multiply throughout by -1. If you multiply throughout by -1, then what is the value we will get here? Minus log of H3O plus. Okay. Here next one, minus is the multiply with that one. Minus log of OH minus is equal to minus into -14. That becomes the +14. Yeah. So when you see this one, what we are observing here? Negative logarithm of base 10 to the hydronium ion concentration, negative logarithm of base 10 to the hydroxyl ion concentration. We have studied that minus log of H2O plus is what we are going to say. We are going to say pH here. Then you have to write pH. Okay. Plus negative logarithm of OH minus is called what? POH. That is the definition. I had explained only. That is what written POH is equal to what? Is equal to 40. That we have proved that. We have proved that what? pH plus POH is equal to 14. Okay. pH plus POH is equal to 14 is the means also we can write out this expression. It is also we can write on what? pH plus POH is equal to Kw. We can also write it what? pH plus POH is equal to Kw, ionic product of water. So these two expressions are there now. That is very important for your thinking. So in the problems here. Okay. Next one. Next we will take the another one here. There is a problem we have to take here. Calculate the pH of calculate the pH of 0.025 molarity, 0.025 molarity of barium hydroxide, BaOH2, barium hydroxide. Okay. So here you have to calculate what? You have to calculate the pH of a 0.025 molarity barium hydroxide here. So how to calculate here means, so you can use the pH value, expression here. What is that one is there here? That is before that one, what you have to do here means, so first you have to write down the dissociation. How it is undergoing the dissociation is there. So that here means the barium hydroxide solution, barium hydroxide is there, BaOH2, barium hydroxide. So when it is undergoing the dissociation gives what? When it enter Ba2 plus 2 OH minus ions here. So in the question, calculate the pH they are given here. But here it is a base is there. Barium hydroxide is a base is there. Hydroxyl ion concentration is there means, so that is the base is there. We have to find out what pH we have to find out. But they are given what? POH is there here. Okay. Next, what you have to do means, you have to write down the first 0.025 molarity of barium hydroxide is there. Suppose, so here what happens here? How many number of barium is there? That much number of barium is there here. The reactant side and product side they are equal is there. That was studied here. If we are 0.025 molarity is there means, here also it is having what? 0.025 molarity here. That you have to understand here. So here 2 is there. Number of moles is the oxygen is there here. 2 moles is there. Means you have to write down what? 2 into 0.025 molarity. That you have to write down. How much number of hydroxide is there on this reactant side? That much is there, product side is there. But you have to multiply here 2 because here means 2 is there. Number of moles will be 2 is there. Then what is the answer you are getting? 2 into 0.25 here. The answer you are getting what? You are getting the answer is what? 0.05 molarity. 0.05 molarity. Next one. Next, how to solve this one? Next one you see. So here it is the OH minus ion concentration. It is called what? OH minus ion concentration. This is the what we are calling here. OH minus ion concentration. The OH is the OH minus ion concentration. Next, what you have to do here is, you have to calculate that is the pOH of the solution here. Otherwise, you can also this one as a we can also write down for. So we can write down the OH minus equal to 5 into 10 raised to minus 2 molarity. 5 into 10 raised to minus 2 molarity. So next one, we have to write down the formula. That is the what is the formula is there here? pOH is equal to. First you have to find out the pOH. Why? Because means they are given only OH is there. They are not given H plus N here. That is pOH is equal to. What is the pOH formula is there? Negative logarithm of base 10 to the hydroxyl ion concentration. It is equal to what? Negative logarithm of base 10 to the hydroxyl ion concentration. We know the hydroxyl ion concentration. What is the hydroxyl ion concentration is there here? You write down that one minus log the base 10 5 into 10 raised to minus 2 is there here. 5 into 10 raised to minus 2. That I already put the log A into B. What is the formula is there? That we have to apply here. What is the formula getting? That is the 2 minus log 5 we are getting. 2 minus log 5. Directly add here. 2 minus log 5. Then 2 minus log 5 how we are getting here? A into B. Log A plus log B into that we have to write down. That in the last problem only I had solved that one. Then log A m into n, m raised to n, that you have to do. Then after getting the everything, we are getting the answer is what? 2 minus log 5. Then we are getting. Okay. So next one, next how we have to solve this one? There is the two values there. We know that 2 I will have to write down. You have to find out log 5 value. What is the log 5 value is there? Minus log 5 value. The log 5 value will be, when you calculated that one in the logarithm table, we are getting the 0.6990. 0.6990. That is the value rated, log 5 value. So afterwards you minus that one, subtract that one, you are getting the answer is what? 1.301. 1.301. So you find out what? You find out at the pOH. But what they are told here? They are told you to find out what? pH of the solution, not pOH of the solution. So how we can find out, sir, here means by using the formula of what? This derived formula, pH plus pOH is equal to 14. pOH that we find out at that one, that we have to put here. If you move toward this one, 14 minus pOH you are getting. You do that one, you are getting what? pH value. So we will do that one. Next one, I will write on this side. So we are found out the pH, pOH. Then you are write on what? pH plus pOH is equal to 14. That we know here. Means then we have to put that pOH value. pH plus 1.301 equal to 14 is there here. Suppose this pH value if I move this side, then it becomes what? pH is equal to 14 minus 1.301. Okay. Then what is the value you are getting? When you subtract this one, you are getting the value what? pH is equal to 12.699. That is the value. We have found out what? That is the pH of the solution by using what? By using the pOH. First we are find out the pOH. Okay. Then by using the pH plus pOH is equal to 14. That formula we have find out what? pH of the solution. That is what? 12.69 is there. Next one. Next one is what? Dissociation of constant of weak acid and weak base. And dissociation constant of acid. Dissociation constant of acid. We have to write down Ka. Dissociation constant of acid. What is the meaning of this dissociation constant of acid here? In the last class also I had explained that one dissociation constant of acid. So here the ratio of, it is the dissociation constant Ka. It is the ratio of product of molar concentration of the dissociated to ions to the molar concentration of the undissociated molecules of the acid. It is called what? Dissociation constant of an acid. It is the ratio of dissociation constant is the ratio of product of molar concentration, product of molar concentration of dissociated molecules, dissociated ions, dissociated ions to the product of molar concentration of undissociated molecules, undissociated molecules, of acid, it is called what? Dissociation constant. So I will write down the expression, you will understand it easily. That is, we have to write down what? Suppose you take one of the example here. What is the example? Acetic acid directly. CH3COOH is there. So when you are adding the acetic acid in the aqueous form, then what happens here? It forms what? CH3COO minus plus H plus. CH3CO minus and H plus. Write down the dissociation constant of this reaction here means how we have to write down here means Ka. Dissociation constant of this reaction, what is there sir here? This is Ka is equal to what they are from here? It is the ratio of product of the molar concentration of the dissociated ions. These are the dissociated ions are there. CH3CO minus and H plus are the dissociated ions here. That we have to write down here CH3COO minus into product is there here. They are written here product of the molar concentration of the dissociated ions means that we have to write H plus. It is the ratio is there divided by is there here. Next one, to the product of molar concentration of the undissociated molecule. This is the undissociated molecule is there. Then you have to write down here CH3COOH. So this is what we are calling it as Ka. It is the ratio of number of moles of undissociated molecules, molar product of the molar concentration of the undissociated dissociated molecules to the product of the molar concentration of the undissociated molecule. So this is what we are going to say Ka. Here the Ka is called what? Dissociation constant. That you are heard. Ka, it is also called what? It is called the dissociation constant. Dissociation constant of weak acid. Dissociation constant of what? Weak acid. Ka, weak acid. A that indicates what? Weak acid. The next one you are having what? Dissociation constant of weak base. That I will write on here. The dissociation constant of base. Dissociation constant of base. We have to write down what? Kb. That way. Dissociation constant of base. Here also the definition is same is there here. So the same definition we have to write down. The dissociation constant. It is the ratio of product of molar concentration of dissociated ions to the product of molar concentration of undissociated molecules. Undissociated base molecule. It is called what? Dissociation constant of a base. That we are representing. So one example I will give that one for the dissociation of weak base is there. That is we have to take what? NH4OH is there. NH4OH. So it undergoing dissociation. That it gives what? That it using NH4 plus it gives what? OH minus. Then how to write down for Kb? This is constant of weak base. That is Kb is equal to, you have to write down what? What is the product? It is the ratio of. Ratio is the means divided by is the product of molar concentration of the dissociated ions. These are the dissociated ions are there. Then you have to write down NH4 plus into product is the multiply that OH minus. Okay. Next one you see here there is a to the product of molar concentration of the undissociated base molecule. This is the undissociated base molecule. Is there? That one you have to come. NH4OH. So this is what we are calling as the dissociation constant of a base here. Okay. What this Kb represents, sir? Kb is the dissociation constant of dissociation constant of weak base. Dissociation constant of what? Weak base. This is the dissociation constant of weak acid is there. This is the dissociation constant of what? Weak base is there. So this is the what? The dissociation constant of an acid and the dissociation constant of base.